Welcome to my presentation on the face of affect and exertion. My name is Stadeler-Timme, and I'm a PhD student at the University of Potsdam. This recently published study used biometric software, automated facial action analysis, to decode facial and experiential changes that occur during physical exercise. Why should we study the face and affect in exercise psychology? How we feel during exercise has proven to be an important predictor of our future exercise behavior. However, thus far, these responses have been solely measured with self-reports, which can be prone to subjective biases. Therefore, monitoring facial changes with biometric measures could provide an alternative way to learn about feelings that occur during exercise. However, the term facial expressions has recently been criticized by the scientific literature. The construction review criticized that there are no stereotypical facial expressions indicative of specific emotions. Instead, one and the same facial expression can be a sign of different emotions, and one and the same emotion can have different facial expressions. I don't know about you, but have you ever gotten this emoji and had no idea what it actually means? I think if I give you some information about the context, you know how I felt. Therefore, it is important to not just use commonly known facial expressions, like for example the brow furrow for negative affect. Instead, the aim of this study was to identify context and individual-specific facial actions during exercise. This was done by using automated facial action analysis with FDAX, which is an algorithm based on machine learning implemented with the software Emotions. In this study, 113 participants performed an incremental exercise protocol on a cycling ergometer. During that test, affective valence, which is the dimension of affect, and perceived exertion were measured every 2 minutes by verbally responding to the feeling scale or rate of perceived exertion. At the same time, participant faces were continuously video recorded and the changes were analyzed with the algorithm. It tracks the configuration of 34 landmarks in the face and feeds this data into a classification algorithm, which translates these movements into values of 20 facial actions. For data analysis, we used mixed effects modeling to consider how individual changes in affective valence and RPE co-vary with movements in these 20 facial actions. We expected a quadratic decline in self-reported affect when exercise intensity increased. This is also what we found for most individuals. However, as you can see in the subsample, participants showed both intra- and inter-individual variability, which we could explicitly quantify with the ICC and random effects. In the next step, we looked which facial action was linked to which feeling during exercise. The facial action mouth open was related to both feeling scale and RPE. However, just the random effect for RPE was significant and therefore included in the model. The facial action nose wrinkle was significantly associated with affective valence, while jaw drop was specifically associated with RPE. These results led to the conclusion that we could replicate previous research by showing that with increasing intensity, affective valence follows a quadratic decline. Additionally, we could explicitly quantify the significant inter- and intra-individual variability. Further, both affective valence and perceived exertion could be captured using automated facial action analysis. Thereby, this study provides practical foundations for future research, examining affective responses during exercise, which could, for example, look at other modalities like running or using respiratory gas exchange analysis to physiologically determine individual exercise intensity. Thank you for listening to my presentation, and I would be happy to come in contact with you, so feel free to reach out via mail or Twitter.